Right, a very good afternoon to everyone here. Thank you all for coming to this session. My name's Alex Whittles. All my contact details are on the screen. Please do feel free, if you have any questions that we can't cover today, drop me an email, a tweet, or etc., and get in touch. Happy to talk about anything Microsoft Data, Power BI, BI, etc. A bit about me before we start. I'm on the SQL Bits Organising Committee, so on behalf of the committee, thank you all for taking the time to come here. It's great to have you back in person again. I run Purple Frog, a Microsoft data analytics consultancy in the UK with a worldwide customer base, focusing on all aspects of data warehousing, ETL, Power BI, machine learning, etc. I'm a data platform MVP, has been for 7, 8 years, I think. And then I also run Power BI Sentinel. So if you've got any needs for Power BI governance, disaster recovery, auditing, visibility on who's got what permissions, automated backups, change tracking, etc., 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 have a look at Power BI Sentinel. It is an awesome tool. When I'm not doing that, I'm also a qualified pilot. That was when I got to fly a Spitfire a few years ago. Very fun day, highly recommend it. Right, what are we talking about today? We're covering Power BI advanced data models. What does that mean? Boiled down, it's really about how do you get data into Power BI. We know there are limitations on size. You can't bring an infinite amount of data in. So how do you go about bringing more data in than you need, real-time data, things like that? We're talking about combining different types of data ingestion into composite and hybrid models, combining multiple different styles of data ingestion together, and then using that to then layer logic on top of each other to get ultimately quite a complex data world with a very scalable, manageable set of data in Power BI. And then that then leads on to actually improving our data management within our Power BI environment. So what does that look like? Well, let's go back to basics. Back to day one in Power BI. How do you get data in? Well, still to this day, the best way of getting data into Power BI is to import it. You suck the data out of your source database and bring it into Power BI. It compresses it, uses the Vertipack engine, 10-to-1, is really fast, etc., etc., etc. Then we look at direct query. You leave the data in the source database. Power BI acts as a pass-through layer that converts essentially a DAX query to a SQL query and lets the database do all the work. We'll cover these in more detail as we go through. I want to lay out the idea, the concepts before we go through in more detail. We then have this concept of composite models, where you have some data in your source and some data in Power BI. And then Power BI can then determine where it gets its data from. Once we've got a data set or a tabular cube, I'll use those two pretty much interchangeably for this session. You can also connect to it with a report. So the report is simply using an existing dataset or cube and just visualizing it, and layering multiple reports connecting to the same cube or dataset in a live connection mode. And then one of the more fun parts of this is, I think, possibly the best acronym Microsoft has ever come up with, DQOAASAPBIDS, which I just think is genius. It was going to be called composite models, but then we already have a composite model, so they had to come up with direct query over Azure Analysis Services and Power BI datasets. Love it. And now, if anyone's been paying attention over the last few weeks, a recent announcement was we now have hybrid tables, where a single table can be both import and direct query. So let's look at all these in a little bit more detail with the pros and cons and where they kind of fit in our data world. Import mode. It is simple. You literally say import, pull in data source, and it just pulls it in. Simple, fast. There are no limitations on really what you can do with it. You get access to the full spectrum of Power Query functionality, DAX functionality, etc. Very highly compressed, around 10-to-1, so the data is really nicely in memory. Column store compression works really well. However, your data is only as up to date as your last data refresh. With Power BI Pro, you can have up to 8 refreshes a day, so you can kind of have hourly refreshes through the day or overnight. But you haven't got that real-time nature of data. And also, how long does it take to process that data set? I've got some data sets that take about 5 hours to process. You can't really do that during the day to get any more real-time. And obviously, there's a limitation on size depending on whether you've got Premium or Pro. So if you've got a terabyte of data, a petabyte of data, you can't import that in Power BI. So then you think, well, let's instead use direct query. Let's make the source database engine work for us. And so we'll just have Power BI dataset as the calculation layer, the data model layer. And we can then create visuals on it, interact with it. Power BI dataset will convert that into an underlying SQL query. It'll fire off to the database, bring back the data. Now that sounds like a really, really good idea because you've always got real-time dashboards. The data is up to date as your data in your source database, until you actually start to use it and you realize quite what a bad idea it is. You will always find a performance issue because the performance can't use the data already in Power BI, can't use that compression, the Vertipack performance that you get in Power BI. You also have very limited Power Query. If anyone knows anything about query folding, it's the ability to take a DAX statement, convert it into a SQL statement, not create a DAX, create a Power Query, and take that Power Query and convert it into a SQL statement. So if your first step of a Power Query is a filter, is a where clause essentially, it won't bring all the data in and then filter it in Power Query. It will actually embed that where clause in the SQL query, pass it down to your database, and bring in a limited set of data back to Power BI. Query folding passes the workload down to the underlying database. Now, if you're in import mode, you can have a combination of both. Functionality in Power Query that can be query folded down to your database, and then some stuff that can't. Well, if you're in direct query, every single interaction with your visuals has to go back to a SQL query. So you're limited in Power Query functionality to only that functionality that can be query folded. You've also got limitations on DAX. Things like temporal calculations, month to date, year to date, things like that, you cannot do in direct query. It also puts a massive workload on your source system. We've got a customer who runs a number of real-time dashboards around their manufacturing center, pulling data in real time off a Dynamics AX system. And I think the 8 dashboards we have for them occupies 95% CPU on that server 24/7. You can't do that on a production system, so we have to have an always-on clone and run the dashboards off that. So yes, you're getting real-time Power BI, but there's an expense there on having to have an always-on clone of your operational database. So be very careful of that performance. And there is also a limit on how much data can come back. It's 1 million rows. That is 1 million actual rows. So if you've got a grouping in there, it'll group it as long as the results of that are less than 1 million. So in reality, not a major limitation, but one to be aware of. So what if we want to have a combination of of those first two? We can have composite models where we start to say, we want the performance of an import mode, but actually there's too much data to import everything. So why can't we import some and have some in direct query? Now originally you could do that, but you had to have 2 different tables. One which was in direct query, one which was in import mode, and then write your own DAX to say, what should I look at, and go to one table or the other table. However, now we have that built into the Power BI engine, so it'll handle it for us if we set it up right. And so we'll look at that in a minute, and as an example. Now, this is great because it gives us the ability to have an unlimited set of data in terms of size, and we can decide what's going to be imported and what's not. But it does mean you've also got 2 different performance characteristics. You add one filter to a visual, and it's really nice and fast. Add another filter, and it becomes really slow. And that expectation management with your audience, with your consumers, is actually quite important. Because what you don't want is them to say, yeah, this is a great report. Oh, it's broken. Log a ticket. Well, no, it isn't broken. It's just slow because you've added an extra filter. And we'll look at why in a minute. So what does this composite model look like? How does it actually work for us? Well, let's assume we've got a system that tracks views on a website. We've got 3 core dimensions. We've got the web page on the top left. We've got our date and time. In the middle, our fact table, which is our website hits, number of hits on a particular page. Now that may be terabytes of data. If you ever looked at web logs, they are quite significantly big. Out of those 3 dimensions, which ones are going to be the most important, covering 80 to 90% of our reporting? I would say web page and date. We're going to want to know how much activity did each page get over a period of time. Is that getting more or is it getting less? Time, yes, it's going to be important for some niche reports, But who's really going to want to know at 10 in the morning how many hits did you get? Yes, it's going to be important, but it's going to be the minority of reports in this case. So what we can do is we can add another table of an aggregated set of data that aggregates our source fact table from our data warehouse or data lake, that groups it up to one row per page per date. And then we can store the aggregated data in there. We still have our other table in direct query, which links to our time table as well. So we could just write a DAX statement that says, if we have a filter applied to our time dimension, use the direct query table, otherwise use the fact table. Use the aggregated table. But then you've got two different tables in the model. Users are going to start to get a little confused as to what's what. So with composite models, we can actually blend those through together into a single conceptual table the Power BI will manage. So let's have a look at that in action. So I've here got exactly the model that we just looked at. Hopefully we can all see that. But I haven't got the fact table in the middle here. So let's add that. I'm going to bring in data from an Azure SQL DB. And this is AdventureWorks DW 2016, and I'm going to bring in my fact web hit. I'm not going to transform it, I'm going to load it straight in. I'm going to bring it in direct query mode. Now, for some reason, it always puts it over to the right, so we're going to bring it in. Now, straight away, there's a couple of things to look at here. That's blue, that's white. The color on the bar indicates there is a difference in the model type of that table. So you can very quickly get a visual representation of why are two tables different. If we hover over a table, we can also see that's in direct query. If we hover over a white table, we can see that's in import mode. So we can link these together as we would normally. Let's link date key. Let's link our time key to our time dimension. I'm going to skip validation because I'm brave. And our page key over there. And now I'm going to add a measure to this table, this blue table here. So let's add something like average duration. And that's going to be the average of fact web hit load duration. Now, once we've got that, this is obviously a direct query. So as soon as I bring that into a visual, you can see the little spinner at the top. That is going to go and convert that DAX query into a SQL query, fire it off. I've got a cache in there. I'm going to do something on this to prevent it using the cache. Let's add in calendar year. See, that's the problem with practicing a demo before you actually do it. It leaves things in cache for you. That should hopefully, well, it'll take a little bit longer, but not actually that bad. But normally this takes around 6 to 7 seconds, depending on the size and power of your underlying database. Some of these, obviously, in a big data set, could take hours to run. But normally, you want them to run a little bit faster. Let's just get rid of that and put month name. It's not as snappy as you want it to be. You want it to be that little bit faster. There you go, that's better. So let's now add our other table. So I'm going to drop those down a bit. I'm going to use my recent sources, bring in the same database. But actually, if I jump off to Azure Data Studio, we can see that I've created a view in this database. There we go. Called fact web hit page date. Now, this is simply loading the same table, grouping by date key and web page, with a few, like there's a sum of our load duration and our count of rows. So I can use the two to create an average. So I'm going to bring this table in. We could have done this in Power Query, but it's easier and quicker to show you in a view. So I'm going to bring in that view. That one there. And this one's going to be already. Okay. An import mode. It's a 50-minute session, isn't it? Ooh, panic. It is a 50-minute session, not a 20-minute session. I'm only a third of the way through. It's dreadful. Right, panic over. So I did that in import mode. So I've now got another table here. And again, if I hover over this, we can see it's a white table, and that should show it in import mode. So how do I tell Power BI that these two tables are essentially the same thing? Well, I can right-click on this table and manage aggregations. And this is going to allow me to define what these different columns do. So if we saw on the view, what did the view do? Well, it loaded the fact table and then grouped it by date and web page. So let's say date is a group by, and so is the web page. That was also a group by. The table was the fact table. And which column is being grouped by? The date key, and that one's the web page. So we've basically given Power BI the definition of what that view or what that table actually is. And then we're going to do the same with the other ones. Load duration ag was a sum in our view of our fact table and the load duration. The row count is a count of rows of that same table. Now note you can select the table here. So you can have one aggregated table that actually aggregates multiple direct query tables if you wanted to. Our web hit count is, let's say, count of our primary key in our table, web page key. So note at the top, we also have a precedence. If we wanted to have multiple aggregated tables, all aggregated by different things, like one table, web page and date. One table could be web page and hour or time, something like that. You can do that, and you can define which one is the priority to be hit. We've only got time to do one here. So let's apply that. Now note, as soon as you do this, it sets your aggregated table to invisible automatically. So if we go to our visual front end, you cannot see this aggregated table. From a user's perspective, they still see the direct query table, and Power BI will determine whether it can actually do a better job for them by using the aggregation. Now then, before I do anything with this, I'm going to go into Azure Data Studio. I'm going to go to my database, click Alt-P, and start a profile trace over my Azure SQL DB, just so we can see what it's doing in direct query. So if I do something like, now we know that the aggregation doesn't touch the time dimension. So if we bring on something like time hour and filter by this, we know it should still hit the direct query. So we do that, and we can see that that's still spinning quite happily, going to go on for a long time and give us a direct query, which it does. That's what we expect. Let's go and have a look at our profile trace and see what that looks like. And we can see here that it is pulling in our table. It's creating a where clause. It's finding all the different time keys in the data model that apply to the filter we applied, passing that down into our SQL query, and letting our database get the results and aggregate it up, getting the sum of all of our load duration and the count of all of our rows. That's doing this aggregation for us. And that's what we expect, because we're using time, which isn't aggregated. So with that in mind, let's get rid of that filter. And let's now add a filter using, let's go for month number. And when we filter by, in fact, let's change this to year, calendar year. So in theory, if I filter by a month number, it should hit our aggregated table. But it doesn't. There's a problem. So we've created this aggregated table. We want it to be really, really nice and fast, like an imported table, but it doesn't. And this is somewhat of a challenge to figure out why that doesn't work. And there's a way we can try and figure out, well, what's it actually doing? Is it hitting the aggregation? Well, first of all, we can go back to our profile trace. we can look at the last query, and we can see it's still doing this direct query. It's still hitting it, and there's the date key. We know it's filtering the date table. Why is that? Well, it's because of the way that I created the aggregated table. And that is one of the tricky challenges of how these aggregated tables work. So there's a way of debugging this using external tools. We're going to go into DAX Studio. We're going to only use this for a really nice feature which gives us the server and the port the Power BI is running on locally on my machine. And I'm going to copy that, and I'm going to load up SQL Server Profiler. And I'm going to start a profile trace locally on analysis services using that same server and port. And under my events, there's a new event under query processing called aggregate table rewrite query. And when I do this, it's going to tell me what Power BI is doing when it's trying to interpret that aggregation. So let's interact with this again by changing the month filter. And let's go and see what that trace has said. We can see that the attempt has failed. And it's failed because we are missing an aggregation. And it's trying to get an aggregation on load duration. Well, what are we expecting? And this is the aggregate table that it's trying to hit. It's trying to get a sum of load duration. We know that exists because we added it. A count of load duration. Well, we did add count, but we added count on the primary key of the table, not on that particular column. And that is the clue as to what's going on. So let's go back to our data model. Go back to our aggregate table. And this is the issue here. When you're doing an average of a column, you need the total of the column and the count of the column. Divide one by the other and you get the average. We're doing the total here with the sum, but our count is counting the primary key, not the load duration. And in Power BI, if you have null values, that is important because they are excluded from a Power BI average. And that's why there's a difference. So let's change that to count our load duration column. So now, if we want the average of our load duration, we've got the sum, we've got the count, we know everything should work. Let's apply that. And hopefully, if we now go back to our model, we can interact really, really fast. And suddenly, we're getting that data coming from the imported table really, really snappy, as we would expect. So with these composite models, they make a massive difference when the visuals you're looking at hit the aggregated tables, and you can see the performance there difference. But it is quite tricky to make sure those aggregated tables are set up correctly to hit all the DAX calculations that you're using to hit those aggregated tables. Any questions so far? Does that make sense? Question over there. Sorry, can you say that louder? Can you add multiple aggregated tables? Can you add multiple aggregations? Sorry, I've got to come over here to get the question. Sorry, shout again. Second filter on page. Good question. OK, right. So can you add multiple filters on this? And will that still hit the aggregated tables? Absolutely. Because the aggregated table is simply saying, all the filters that I've got applied, is there an aggregated table that actually hits that? And so if we look at our data model, our aggregated table comes from web page and it comes from date. Therefore, any filters on both of those will be able to hit that aggregated table. The only table here that isn't linked is time. So it knows if we try and do that, there is no aggregation link there, therefore it can't use it. So let's show that in action. Let's add another visual filter to our fact web page. Let's look at subsite. And if I click that, you can again see the performance of that. So any filter applied, whether it's in DAX or visual, on any tables that are included with a link to that aggregated table will get hit. But always, when you're doing this, open up that profiler and keep an eye on this so you can actually see all of these rewrite queries here So actually, we can see this. There we go. Match found. It found a match in that particular table, and these were it was looking for a count of that table, it was looking for etc. So always have that profiler ready to debug, and that will save you a huge amount of time trying to get this to work. Any questions from the remote attendees yet, or are they all quiet? If you are remote, we will take questions. Sean here will read them out to me. Okay, so what have we got next on here? Okay. So in this model, we've got our imported table, we've got our direct query. They're all grouped into one. So this is our composite, imported and direct query. This is obviously a very simple model. In reality, you're going to have a lot more tables than this. What you don't want to do is have to go through the pain of creating all of this every time you create a large data set. Now, this is improving. This is going to become automated at some point. At the moment, it's all manual, but there's work being done on making this a lot more, a lot less manual work. But at the moment, there is a lot of manual work. So once you've created this, you then want to expose the functionality of this to other people in your organization so they can create other reports using this model. So first of all, let's save this. And once we've saved it, we can publish it to our service. And I'm going to put it in the SQL bits workspace. Okay. And then we can go open up a new Power BI. And once we've got this, we can get data from Power BI datasets. And as long as I've got permission to see that workspace, which I do, then it'll give me a list of datasets that we can consume. So I'm going to bring in a live connection, this is called, to that dataset. I can see the tables. Note that I can still only see the single direct query table. So let's see what happens with this. Now, obviously, this is in live connection mode. So you can't view the tables. You can't see the data inside these tables because that's off in a different data set somewhere. This is just bringing in the tables that I can see, so I can start building some visuals. So let's bring in our average duration. So this is now going to create a DAX query, fire it off to the data set that's currently up in PowerBI.com, and give me the results. And let's look at some of this performance. So let's bring on a filter by year. And as we'd expect, that is hitting the source database, or the source data set, pretty quickly. The response is coming very quickly, so we know when it's firing off our DAX query to our data set, the data set is doing that aggregation for us and hitting our imported data. If we add a filter by time, as soon as we do that, we get the spinner again for 7, 8 seconds. So even though we've connected to this data set in live connection, when that DAX query gets sent off to that data set, it's still doing that hybrid, that's the wrong word, composite of either direct query or import for us. But from this perspective, we don't know about that. We just see it as a data set. And this is one of the challenges with managing user expectations of they connect to a data set and they expect consistent performance. And when one visual takes 50 milliseconds, one visual takes 8, 9, 10 seconds, 30 seconds, there's a problem with expectations there, and they log tickets to the fact that everything's broken. So do be careful of when people are using these composite models that they do understand what filters they should avoid to get the fast performance. But the functionality is exactly the same. But now we don't have to worry about the complexity of the model from this perspective, we can just use it. So there are things we can do with this. Obviously, someone else has built this data set, and we want to write some reports, and we want to add our own custom measures on there. And we can do that. We can, on sorry, there we go. We can then add our own measure onto there. But that's it. You can't do anything else with this data model. This data model, this data set is pretty much fixed in its structure, in the tables it's got, the relationships, etc. What if we want to enhance this? We always talk about a 3-layer data set management. You've got those data sets that are single version of the truth, created by the central BI team in your organization, that really are a data set to be used by the masses. Then every department is going to want to add their own flavor, their own additional information, reference data, Excel reference, or whatever it may be, and enhance it further. And then every individual is then going to want to take their departmental data and enhance it even further. So how do we enhance this? We can't, because it's a fixed data set in live connection. Well, we can if we look at our modeling. We get a button saying make changes to this model. There's also an option down the bottom, at the very bottom right, make changes to this model down there. So this takes us, if we do that, it takes us out of our live connection mode and brings in this wonderfully acronymed DQOA SAPBIDS, direct query over datasets. So let's do that. This says we are going to add a local model. So that's going to take the structure of our underlying dataset and bring in a mirrored clone of that structure, not the data, the structure, and essentially make every table a direct query to a data set. It's not quite as simple as that, but that's conceptually one way you can think about it. But it's not direct query to the underlying SQL database or data lake or whatever it is. It's direct query to a data set or an Azure Analysis Services cube. And when you do that, it messes up your data model layout every time, which is really frustrating. So let's move things around. Our fact table's there. That's our aggregated table. Our date is over there, and our time dimensions down here. So that is the same data model we created earlier. This is still showing as invisible, which is good. Note they're all showing in the same color now. They're all blue, because they are all direct query over a data set. It doesn't know about the internals. That's the other data set's issue. But what this now means we can do is we get the ability to bring more data into this data set. So I'm going to bring in more data from, in this case, the same SQL database that I was using earlier, but in reality it could be something completely different. And we've got a great data set here that talks about the website performance. But in the sales team and marketing team, I want to enrich that. I want to see not just website performance, but I want to overlay sales data with that, so I can see if there's any kind of correlation. I don't want to have to write my own website, web page, web hit analysis. I want to reuse what's been done by my central team. So I can just import more data from Fact Internet Sales over the top of this model. And I can choose import or direct query. I'm going to choose import here. This is giving me a potential security risk. What's that all about? Well, we saw earlier when we looked at the profile trace, when we filtered by date, it built up this long subquery of all the different date keys that were relevant to that particular filter and sent that down to the database to say, please filter these keys. If your data is coming from multiple different databases, you can have data from one database being sent in this manufactured query to another database. And that potentially may contain email addresses, sensitive data, whatever it may be. So it's just saying we're passing data from one data source potentially to a different data source. You may want to be aware of that. That's all that's saying. So now what have we got? We've got another table here, Fact Internet Sales. Now we've got two different islands of data now. We've got our direct query island in blue, and we've got our Fact Internet Sales in our white island. What good is this? Well, not much at the moment, because we want to see a nice chart overlaying website hits and sales on the same time. To do that, we need a common dimension, date. Luckily, they all both contain a date key. In this case, let's look at the order date key. So I can create a connection between these two islands based on that column. So now, when I filter by dim date, it's going to propagate that filter across to whichever fact table is relevant there, and to this in a different island. So let's see that work. Before we do that, I need to add some measures. So let's add something like sales equals sum of fact internet sales amount. So then on our view, we can then add our measure. Let's put that in a table so we can see them both. And I'm going to drag month onto there so we can see the split. So we can now see that in this visual, we've got data from both of our underlying tables. Now, if I filter by year, it's going to filter both of them, because that common date dimension propagates its filters in both directions, filtering both of the islands of data. Obviously, if I filter by web page, that dimension has no links to sales, so it's going to make no difference at all. If I filter by hour or time, again, that only has a connection to our website hits. So it knows it's going to go in direct query on our direct query island. So that slows down the whole visual. But that is then coming from direct query to the dataset, which in itself is doing direct query to the underlying database. This is being completely unaffected by the hour because there's no relationship, but it is being affected by the year filter. So we're starting to build quite a complex model here of lots of different types of data ingestion with direct query in 2 different flavors and imported in 2 different data sets. Any questions on that? Yes, can we go to the relationship view? Okay, good question. This dim date is in direct query mode of the underlying data set. Would it be more effective to change that into dual mode? You can't here because that's in someone else's data set. In this composite model here, or this direct query model, we cannot change the actual tables that are in DQ mode to the underlying data set. That's the other data set issue. And there it's in imported mode, so that's fine. We can connect stuff to it, but we can't change that fundamental data model. So all of the relationships between these DQ tables, you can't change. All we can do is enhance it with more. Now, what you may want to do is decide where your common dimensions are going to be. Are they going to be in your underlying DQ model? Or do we want to bring dim date into this model so we can do more stuff with it? Now, if most of the reporting that you wanted to do is of your own imported data in this model, I would say, yes, it makes sense to bring that date dimension into this model so everything's within one data set. And then only the data that you want to bring in to supplement it from the underlying DQ model is going to come in. So in that case, you may want to have 2 date dimensions that are joined by date key, hide the one that's coming in from the other model, and then that would help manage that. So yeah, you can have these duplicate dimensions, but they have to share that same business key, date key, web page key, time key, etc. And that's one of the challenges here, is you've got to have common granularity between the 2 systems. That leads on to performance. Question?
You have shown a composite model using direct query and aggregation tables. Have you ever seen any need to use a composite model with a model that uses only imported tables?
Cool, that's a question, Sean. So I showed a composite model of 1 direct query, 1 import. Have I ever seen one using composite of 2 imported tables? No, I haven't. I would question the reasons why you would want to do that. The use case for that would be fascinating, because the reason to do that is because you've got a vast amount of data in a data lake or a data lakehouse, data warehouse, whatever, and you don't want to bring the whole petabyte of data or terabyte of data in. So you want to have this aggregated on the imported. Once you've imported the data, it's going to be pretty fast. If you have a table that's imported and still slow, then that may be a use case for having an aggregated imported table, but I've not come across a scenario that that would actually be necessary in. But I'd like to see the scenario of it. I'm not sure whether it's even possible. I presume it possibly is, but I don't know. Okay, so let's talk about the performance of this. We saw that it builds this virtual query where it takes all of your filters and passes them down through to the SQL statement earlier. It does exactly the same thing to the DAX statement in the DQ on dataset model. So the performance of your composite DQ model is therefore going to be largely controlled and dominated by the number of values in that join. So if you've got a date dimension, you've got 365 values a year, you've got 10 years, 3,500 members in that join. That's going to work pretty well. If you've got a couple of million customers and you decide to use customer key for that, that's going to have to build this virtual table with a couple of million values to then pass backwards and forwards. And that's going to have a massive impact on the performance of that model. So be very, very careful how you define these joins, because that will dictate the performance of that composite model. I call it composite model because it's easier than DQOA, SAPBIDS, but composite model in this case. Okay. So the next question is fact internet sales. This is imported. Let's say we have a dataset refresh every night. So we're therefore going to have potentially quite a large data volume in that table. Hopefully we're performing well, we're selling lots of products. But I don't want to have to refresh the entire table every single night, because it takes 5 hours to load the data, hits the source system, etc. So we can define that table to be partitioned instead. So on the table, we can right-click and we can enable incremental refresh. And we can say that this table is going to be partitioned up into lots of different date-based segments, and we only want to refresh the new ones. But it's saying we can't. We can't do this because we haven't set up the parameters yet. So we need to create the parameters. What do we do with that? Let's go back into Power Query. And we just need to create a couple of parameters. So we're going to create the first one called, I'm going to get the spelling right because it is case sensitive, range start. We're going to give that a date time data type. And we're going to default this to, I don't know, 1st of the 1st, 2022. Okay. Nope, sorry. And we're going to add another one of range end. And that's again going to be a date time, and default that to the 1st of the 1st, 2023. Now we've got that, we have to tell Power Query how those range parameters apply to a particular table. So we want to apply them to our fact internet sales. Note we can only see this table because all the other tables are in DQ to the other data set. That's the responsibility of the other data set. So I'm going to apply a filter. Sorry, let me get the full screen so I can see what I'm doing. Where are we? Hang on. What am I doing here? What am I looking? What am I looking? Where's my filter? Thank you, sorry. I'm having a difficult to see the screen. There we go. Somewhere here I've got a date time of, there we go, order date. And I want to apply a filter between two dates. So instead, I want it to be after or equal to a parameter of range start. and I want it to be before a parameter of range end. So that's going to apply this filter to that table. And I'm going to come back in here. And then I can apply my incremental refresh. Now it's enabled. And I'm going to incrementally refresh this. I'm going to archive data starting, I don't know, 3 years. And I want to incrementally refresh data, let's say 7 days. Now, once I do this, it's going to automatically create a whole load of partitions of my data. Power BI will then automatically manage which partition to refresh. And because we've added the filter into Power Query, it'll manage the data from and to, and it'll pass that down to our query and give us a nice optimal refresh. But that is only part of the challenge. That makes our dataset refresh much faster, but we're still limited to data that was available at the date and time of the last refresh. One of the newest features is this get the latest data in real time with direct query. So what this will do is create this new hybrid table where the latest partition, today, this week, this month, whatever you define that as, will be automatically in DQ mode to the underlying database, whereas the other partitions are going to be imported. So if I do that, then there's all sorts of other settings in there which I haven't got time to go through the details. But if I go back to a slide, then that creates a list of partitions like this, where you end up with yearly grouped partitions the Power BI has managed for you and just aggregate everything together. The more recent stuff, the yellows, are the recent daily partitions that have been processed day by day by day. But the most recent one there is in that DQ. So now we've got this. We've basically got quite a complex overall model. We started out with our original data set with these 2 different fact tables in there, which we then blended together into that composite model. We then pulled that in through a direct query to that data set, which we then enhanced with this other fact table, added partitioning to that with import mode and direct query into this new hybrid table. So you're pretty much hitting every possible type of data ingestion into Power BI in one data set to really tweak and tune the functionality that you want to get in terms of latency, in terms of size, in terms of performance, in terms of flexibility, and in terms of customizability across the team. So just to very quickly summarize the key different models we've looked at. Import mode is still the #1 choice. It is still always going to be the fastest way of getting data into your reports and the fastest way of visuals being refreshed. So always use that if you can. Only look at other options when you need other options. Direct query, just don't. Avoid it wherever you can. It is not a good choice in the vast, vast majority of situations. However, composite models are really where you want to look at DQ, where you have massive data scale, because the composite nature gives you the performance that you lose on DQ, but it gives you that ability to have very, very large data sets while still maintaining some performance and user experience. So that's really a big data focus. Live connection, whether it's to cubes or data sets. This is all about centralization. One version of your data set truth that can be reused by many reports. If you've got 20 reports, you don't want 20 data sets. Try and think of the cube mindset rather than the data set mindset. A few very large complex data sets rather than lots and lots of tiny data sets. Then we have our DQ over AS and DS, where you actually then enhance that and allow teams and individuals to then really do more with that information. So that's in adding customization to that centralization. And of course, now we take those first 2, the import and direct query, and combine those together into our hybrid tables. So this then gives us that ability to have big data with live data as well inside the same table. So hopefully that's given you some idea about where to look on importing data to achieve different goals with your data set. Don't have one rule for everything, because every data set needs to be different depending on the nature of the data, the size of the data, the latency of the data, the use case of it, and what your actual purpose is with it. So every time you're building a new report, think about all those different concepts as to what the use cases are going to be, and figure out which combination of those is going to give you the results you need. So we are out of time, but I will hover around afterwards for any questions that you want to take after the session. Please do take some time to leave some feedback for this session and all the sessions you see. We want to hear what you like, what you want to see more of, etc. A big thank you to AV and the helpers here, and thank you for coming to the session. Have a great rest of the day. Thank you.